The International System of Units is the SI system, and this is what we use in the sciences. And we're also going to look at some conversion problems in this second part of Chapter 3. First of all, the SI system has 7 base units. Everything else is derived from these 7 base units. Now, the first 5 are of specific importance to us. The meter, that's length. Kilogram, that's mass. Kelvin is temperature. Second is time. Mole is the amount of something. So the first 5 we're going to use quite often in chemistry. The last 2, candela, which is light intensity, and ampere, which is electric current, we don't focus on those 2 very often in chemistry. Prefixes. Prefixes are used oftentimes just to make writing the number easier. So these are just kind of shortcuts when we're writing measurements. So I want you to know all of these prefixes and what they mean. So we got giga, mega, kilo, hecto, and deca. And these are the ones that are bigger than 1. And the 10 to the 9 or the 10 to the 6, those always refer back to the base unit. Let me give an example of why we need to be able to use prefixes. Let's say I have a measurement, 7.8 meters, and I want to convert that to megameters. Well, I'd need to know what the prefix mega means. But the way we're going to set these up, dimensional analysis, just take your given 7.8 meters, put it over 1. Cancel units, so meters has to go down here, and that's my base unit, meters, and then I can go directly to a prefixed unit, which is megameters. Now, mega means 10 to the 6th, 1 times 10 to the 6th. This 10 to the 6th refers to the base unit, so that goes in front of meters. Anytime you see a prefix, you put a 1 in front of the prefix. In this case, it was mega, but I'm going to put a 1 every time in front of the prefix. Units cancel, I get megameters. So you do the math, 7.8 divided by 1 times 10 to the 6th. And we are paying attention to significant figures, so we get the measurement now, 7.8 times 10 to the negative 6, but now we're in a different unit, it's megameters. As far as sig figs go, 7.8 has 2 sig figs. The 1 times 10 to the 6 is a defined quantity, so that's unlimited. So my answer should have 2 sig figs, and the way I've written it, it does indeed have 2 significant figures. Those are the prefixes greater than 1. Here are the prefixes less than 1. Deci, centi, milli, micro, nano, pico, and femto. And again, the numbers 10 to the negative 1, 10 to the negative 2, those refer to the base unit. So for example, let's say I have this problem. I want to take 6.4 times 10 to the negative 3. Say it's decimeters, and I want to convert that to nanometers. I'm going to start with what I am given, 6.4 times 10 to the negative 3. Let's put it over 1. I'm starting with a prefix. I have to go back to my base unit. Well, decimeter, my base unit, is just meter without the prefix. What does deci mean? 10 to the negative 1. And that goes in front of my base unit, the one without a prefix. So the 10 to the negative 1 goes up here. In front of my prefix, you put the 1. That gets rid of deci. Now I have my base unit, meter. I want to go from meter to nanometer. Anytime you see a prefix, put a 1. What does nano mean? 10 to the negative 9. That goes in front of my base unit, which is meters down here. And so I went from one prefix to another prefix, deci to nano, and this is a 3-step problem. So when you enter this in your calculator, you would get the answer in nanometers of 640,000 nanometers. Sig figs. I start off with 2 sig figs. This is a defined quantity. This is a defined quantity. All prefixes are defined, and so I should end up with 2 sig figs, and 640,000 has 2 significant figures. Let me go through one more, just so you kind of get the idea of this. Let's say I have 3.3 10 to the 9th micrograms. That's what micro looks like. I want to convert that to gigagrams. Okay, I'm going to start with what I have, 3.3 times 10 to the 9th Put it over 1. I'm going to go back to my base unit. My base unit is gram. So I'm going to go from micro back to just gram. I put a 1 in front of the prefix. What does micro mean? 1 times 10 to the negative 6th. That goes in front of my base unit, which is grams. Once I get back to my base unit, I want to go to another prefix, giga. Anytime you see a prefix, you put a 1. And what does giga mean? Goes in front of my base unit, which is 1 times 10 to the 9th. I started off with 2 sig figs. These are unlimited sig figs because they're defined, and so I should end up with 2 sig figs. Sometimes the hardest part is putting this into your calculator, so make sure you can get the same answers that I'm getting as you go through these. But that's prefix units converting between prefixes. Okay, here's some other SI units. Units of volume. The unit for volume, length times width times height, which is meter cubed. Volume is the space occupied by a sample, but oftentimes we're going to use a common unit. We're going to use liters, and that's what we're going to use in here. Actually, we will use milliliters quite frequently, but the common unit is liters, especially when you're measuring liquids. I don't ask you to know many conversion factors, but this is one I want you to know. 1 milliliter is always equal to 1 cubic centimeter. Temperature. The SI unit for temperature is Kelvin. In the US, we use Fahrenheit. In other countries, they use degrees Celsius, but the SI unit for temperature is Kelvin. The temperature. Here's some conversions between the different temperature scales. Now, these are the two that you need to know most frequently. If you need to convert Celsius to Fahrenheit, I will give you these if I require you to convert between Celsius and Fahrenheit, so you don't have to memorize those. But Kelvin to Celsius, that's a pretty easy conversion. The temperature starts at 0 Kelvin. That's why the Kelvin scale was introduced. 0 Kelvin is the lowest temperature possible. So the Kelvin is the SI system, the SI unit for temperature. Unit for energy. The SI unit for energy is the joule. Energy is the capacity to do work or produce change. We don't often use the joules when we think of energy. We use calories. So there's the conversion between joules and calories. Now, actually, this calorie that I've introduced right here is not the same as a food calorie. There are 1,000 of these calories in one food calorie, and a one food calorie is usually the capital CAL. Here's some additional units. Time, we use second. Amount of substance, we're going to use the mole, and we're going to get into the mole quite a bit in the second semester. Force, we're going to use Newton, that's a derived unit. And pressure, we would use Pascal, which is also a derived unit.